In this video, we're going to take a look at the audio listener and the audio source components, which are your bread and butter components. You absolutely have to have these in order to get sounds in your Unity games. Now, the audio listener is very quick and very easy to talk about. We already have one on our main camera. Now, in this case, I've got my first-person controller already in the scene, but even if you didn't, and you just had a regular main camera in here, you'd see the audio listener. It's at the bottom of my inspector right now, and you'll notice it has no properties whatsoever, which makes it very, very easy to talk about. It's just there, and it just does its job. It just listens out for any audio that you have in your scene, and it reports that audio back to your PC speakers or to the speakers of whatever device you might happen to have, so that you can hear the audio that's been set up in all of your scenes. There's not much else to it. The audio source, on the other hand, does have a bunch of really cool settings, so let's take a look at that. Now, I have put together this killer, absolutely amazing radio, this boombox that I built out of primitives, and what we're going to do is put an audio source on this object so that we can move toward it and away from it and see how sounds spatialize and play with all the 3D audio settings available to us. So let's go under Component and jump down under Audio, and here are all of the audio components you have access to in Unity. So you can drop in another audio listener if you get rid of your first one. Just please remember that you can only have one audio listener in your scene at any given time. Just remember that. We've already got one on our main camera, so we don't need to make another one. Next, we have our audio source, which is what we will be using in this video. We have reverb zones, and then all of the various filters. Now, these filters are for pro users only, so if you don't see them or you can't access them, it's probably because you're not using Unity Pro. So let's grab an audio source, and we'll drop that on, like so. And then we get this great, big, long, scary, and awesome stack of properties. We have sliders we can play with. We have really cool graphs with curves everywhere. And it's a little daunting for like 5 seconds, and then you just realize how awesome it is, and everybody's happy. Now, the very first property that we have access to is the audio clip. And this allows us to just take an existing piece of audio, and that's what we're going to play. It's kind of like putting the CD into your CD player, and you determine what sound you're going to play like this. Now, although it is very simple, and you might even get tired of listening to it, I have a beep that I've put together. It started off as a quick and easy internet file, and I added an extra second of delay at the end of it, but please keep in mind that this is not a Foley video. If I jump over to this file and I hit play, that's all it is. It's just a beep. So if I actually set this to loop, that's it. Now, the reason I chose that particular beep is that we'll be able to hear the tone of that go up and down as we play with Doppler effect. We'll be able to hear it get quieter and softer as we move toward and away from the source. So for all of its simplicity, it does make all of the things that we're doing with audio very, very obvious. Now, on your end, of course, you don't have to use a beep. In fact, I'd encourage you not to. Let me use a beep just to show you how the tools work, and then by all means, either grab a cool piece of audio off of some library you might have on hand. They do sell those. Or get online and find a nice piece of audio that you can play with and try out. You don't necessarily have to have the exact same sound that I have, but it will make very obvious what the audio system is doing for us. Anyway, back over here in our radio, we now have our beep delay plugged in. You'll notice it says this is a 3D sound. Well, if I click on my beep delay one more time, you'll notice 3D sound is checked. If I was to uncheck that and hit apply for some reason and jump back over to the radio, notice it now says this is a 2D sound. The trick to that you need to be aware of is that this whole area of 3D sound settings is now null and void if this is just a 2D sound. All we have is the ability to pan to the left and pan to the right with the pan 2D slider at the very bottom. So keep that sort of thing in mind. So I need to go back over to my little beep delay sound and make sure that 3D sound is checked, because that way we get all of the cool stuff. We'll click apply, go back over to our radio, and move on. So starting down from here, we have the ability to mute our sound, which of course won't do us a whole lot of good, because we want to be able to hear it. We can bypass any effects that have been applied to this sound. And by effects, we mean things like our high-pass filter, low-pass filter, echo, distortion, reverb, chorus, all of this stuff. If we had applied this by way of adding these components to this particular game object, we can bypass those. It's just like a bypass button on a standard piece of audio equipment. Next, we have play on awake. This means as soon as the game starts, the sound will start playing. If you don't want the sound to already be playing when you start the game, just simply turn this off. Of course, at that point, you're going to have to use some sort of a script to make the sound play for you, because it's not going to play by itself. Because we're not dealing with the world of scripting in these videos, we're just going to leave play on awake on. Next we have loop. Now, because all I have is a single beep, it makes a lot of sense for me to turn this on to loop so that that beep will continue and we can listen to what it has to offer. Now, down from here we have some pretty simple ones, but it depends on how much you've worked with game audio, and actually the tooltip tells you exactly what this does. But priority allows you to establish how important this sound effect is. You have 256 values. You can go from 0 to 255. 0 being the highest priority and 255 being the lowest. The reason you have this is that with most games, you're going to have many sound effects that will be playing simultaneously. You know, if you take like a shooter, for example, you could have multiple players or AI characters firing their guns all at the same time while music is playing, while grenades are exploding and airplanes are flying overhead and someone's barking orders at you over a radio. By setting the priority, you can determine which of those sounds may end up getting knocked out of the way if you've used up all of your audio channels. It's just a way for you to say, all right, well, let's say, for instance, your musical score is critical, because you don't want to break the feel of your game by having your music suddenly switch off for some reason. So you'd take your music and make sure that's at a priority 0, and then if nothing else is at 0, then nothing else will ever bump your music out of the way. It's an important setting to play with, but for us, because we have so few sounds and this is just a demonstration, we're not really going to be able to show it very easily. Now, we have two really obvious sliders down here that are fun to play with. We have a volume slider, does exactly what you think it does. Value of 1 is 100% volume. Value of 0 is dead silent. So you can turn your sound up, you can turn it down. And of course, all of these are accessible via script. We have pitch. And what pitch is going to do is speed up or slow down the sound effect in order to take whatever it is you're playing and make it faster, slower, make the pitch higher, make the pitch lower, and that's all there is to it. And so, as a matter of fact, if I was to just hit play right now, we can hear our little beep. Now, the audio that I am putting out in this video is likely not going to give you a stereo effect, so just understand that as I rotate my camera around, like right now, the sound is coming to me out of my left headphone, and if I rotate around the other way, it's coming out of my right. If you have any sound effect of your own that you're doing this with, you'll notice the same thing. But if it doesn't come back through over the VTM, it's just because we're not actually putting out stereo audio through these videos. And honestly, off the top of my head, I don't know if we are or not. I'm going to guess not. Now, if I play with the pitch slider, you hear the nature of that beep. As I start to slide it down, listen very closely. So that's very slow. And I can raise it. So if you had like the little motion tracker from, you know, Aliens or something, and you needed that to get higher pitch and faster as the critters get closer, you could actually play with that slider through script and make that happen. Now, this brings us to our 3D sound settings, and this is where stuff starts to get cool and just a little bit technical. The first property we have in here is our pan level. And all this is really going to do is control how much your 3D engine is going to affect your sound. By default, this is set to 1, meaning that a 3D sound will make full use of the 3D engine. As you start to slide this down, a couple of things happen. One of them right in front of your face. See this graph down here? This green line starts sliding up and down. This is literally allowing you to map out how much control the 3D engine has over this sound based on the distance from the player to the sound effect. Sound a little trippy? It kind of is, but it does allow for a whole lot of power in terms of how your sound is portrayed. Now, what I'm going to do is let's make a couple of changes. I had to jump around a little bit though because my scene is not very big. So I need to jump down to our max distance. Let's just take a look at min distance and max distance at the same time. It'll make things a little easier. Min distance is the minimum radius of this sound. If you are within this minimum distance, the sound will play back at full volume, whatever your volume slider happens to be set at. So if your volume slider is set to 1, it'll be 100% sound. If your volume slider is set only to 0.75, then it'll only be 0.75 sound, and so on. Now, under this, you have your max distance. This is the maximum sound distance for your sound effect. Beyond this, you either can't hear the sound at all, or the sound has been turned down as low as it'll be able to go. Generally, you're not going to be able to hear it. So let's go ahead and set this down to something very low, like 20. And so what we have is a situation where within 1 meter, we get full volume. In between 1 meter to 20 meters, as we go out toward 20 meters, we get a drop-off, a roll-off of our overall volume. And then outside of 20 meters, we're at our lowest possible volume. You can see that graphed out here, and we'll talk more about this graph in a minute. For now, let's just go ahead and give this a quick test inside of Unity. I'll hit play, and you can hear the beep. And you hear it's a lot louder now. And as we get away from it, it gets a whole lot quieter. Now, if you listen really closely, you can still hear it. But that's because the current roll-off that we have does not take the volume all the way down to 0. So that means that even if we got really, really far away from the sound, we'd still be able to hear it very faintly. If we wanted to make sure that we couldn't hear it, we'd need to adjust this curve. And again, I'll talk about that curve in a moment. Now, the reason I just walked you through min distance and max distance first was so that we can jump back up here to pan level, and I can make that make a little more sense. So let's go ahead and hit play once more and move away from our radio. And now the sound is as quiet as it's going to get. So what I'm going to do is click over here in my inspector. And I hope you can just barely make that out. I'm sure that you can if you listen really close. But as I turn down the pan level, notice the sound gets louder. At 0, the 3D engine has no more effect on this sound. I can run completely away from this sound. It doesn't matter how far I go. And the sound never gets quieter. It never attenuates at all. That's because with a pan level of 0, the 3D engine has no control over the sound at all. So you can just think of that like a control slider for how much effect the 3D engine is going to have over your sound effect. Now, this brings us down to spread. So let me jump over to Photoshop, and I still have my notes from the previous video up here, or from a previous video. Let me go ahead and hide those out. Let's make a new page, and I'll get my pen out. Spread is actually a really cool property, but if you're unfamiliar with what it's trying to get across, it can be a little bit confusing at first. So let's just say this is you. And let's say, for sake of argument, that here's your computer as seen from above. So there's your really cool flat screen monitor, and here's your keyboard. I don't know why your keyboard has that little dent in it, but maybe it's one of those really cool ergonomic keyboards. And then you've got, your front speaker sitting behind everything, and then you've got, your side speakers over here, because you've got some killer audio set up because you're really hardcore about your games. Good for you. So this is a 5.1 setup, and then, for the 0.1, you'd have to have your subwoofer over here, which is one of those, neighbor rattling jobs. Okay, now what spread is going to do, the documentation will tell you that this allows you to spread out the sound in speaker space, and it takes in a number between 0 and 360. And how this works is, if you've got a sound coming from directly in front of you, from the front channel, increasing the spread allows you to spread this out to your other speakers. So if you put this out to whatever angle this would happen to be, this looks like about 150, 160 degrees, this sound would also spread out and start affecting your side speakers as well. If you crank the value all the way to 360 degrees, you'd have a full arc that would reach around and it would affect all of your speakers, even though it was at the front. In effect, you'd end up losing that ability to pan around your sound effect. So if I jump over back to Unity, and we hit play one more time. Now, I can kind of demonstrate this, but again, on your end, you're probably not hearing the shift from left to right. If you are, Cool. I actually haven't checked to see what our audio settings are, and I don't even think we can put out stereo sound in that manner. But on my end, right now, and even if you just have to take my word for it, the sound is a lot more dominant in my left speaker than it is on my right. And if I was just to crank the spread all the way up to 360, I'm now hearing it on both sides. Now, I'm also getting a little bit of distortion in the sound. That's partially because this is such a quick sound, but it's also because of our first-person character controller. You'll notice if you were looking down in my graph that the distance is flickering a little bit. And it's not always happening, and it may not even capture at 10 frames a second for the video, but this just has to do with our first-person controller and its actual location. The first-person controller is moving through code, and each update of the code is telling the controller to move a little bit further. It's not a smooth transition. This will cause the occasional glitch in the sound like you're hearing right now, and it will cause our Doppler level to sometimes sound a little bit flaky. If you have an object that is animated moving through your scene, you won't get that effect. It's just because the way the first-person controller is working. I just wanted to kind of throw that out there. So this does bring us to our next property, which is Doppler level. Now, Doppler level, I don't know if you're familiar with the Doppler effect on sound, but what it designates is that as a sound gets toward you, its pitch, or as it gets toward you, as the sound moves toward you, thank you, its pitch will increase, and that's because the sound waves compress as it's moving forward. Then as it moves away from you, those sound waves stretch out, and so the pitch goes down. It's really easy to hear with police or ambulance or fire truck sounds, sirens, as they roll past you on their way to the nearest emergency. We have the ability to simulate this inside of Unity, and it's on by default. It's set to a value of 1. If you really want to show it off, though, you can crank it up to a value of 5, which is 5 times as much Doppler effect as you would get by default. So we can hit play. And if you listen really close, you can hear that pitch really changing. To help drive it home, though, what I'm going to do is take my max distance, and we'll set this back out to 500. This means, and in fact, on top of that, let me set to linear roll-off. So our decrease in volume will be a whole lot slower, but you'll be able to hear that drop in pitch very obviously. And again, because there's a little bit of jitter in motion with the first-person controller, you'll hear a little bit of a jitter because Unity is not quite sure how much pitch to raise or lower on each individual frame. Again, though, that has nothing to do with the audio system, which will deliver a nice clean Doppler. It's just that the first-person controller is a little jittery itself. A way we can show that is to animate our radio, which I wasn't going to do, but, you know, what the heck, I'll do it anyway. So we'll just select our radio, go back over to Window, and let's open up Animation. Hit record, and let's just call this Boombox Anim. Now, let's see, we want to move this guy in its local X. So we'll select X, drop on a key. Now let's see here. We want this thing to move away from us and then back again. So let's say over 5 seconds. And I'll zoom way out because I'm going to probably put a lot of motion in here. Oh, actually, X isn't going to cut it, is it? Well, let's just... Well, it doesn't matter which one we do because we're going to end up queuing them all anyway. So let's just come back out here to 5 seconds. And we're going to put this guy way over here. So he's actually going to move pretty far over that 5 seconds. And then we'll make sure that our slope type, I'm sorry, our curve type is ping pong. So he's just going to move back and forth. We can stop the recording, close that. Now, let's hit play and just see what we get. They got really low. And now coming back, it's a lot higher pitch. Going out again, it's low. And coming back, it's high pitch again. So you can see how that's working. Now that is a highly exaggerated example of Doppler. Generally you want something to be a lot more subtle than that, so you'd leave this around a value of 1. But by cranking it up to 5, it's a lot easier to hear what's actually going on there. So that's a quick look at Doppler level. Now, since I've got that applied, let me go ahead and delete out my animation curve because I don't really need it. I don't really want my boombox flying around that much anymore. We'll go back over to the radio, and let's take a look at our remaining settings. So we've got our min distance and our max distance. We've already talked about that. And what these do, aside from giving you that control of the fall-off, they also control the extent of what you see graphed out here on your roll-off graph. Now, this roll-off graph has some preset modes that you can play with. You have logarithmic roll-off, which is a lot easier to read if we bring down the max distance, because it just gives us kind of a tighter zoom on what this curve actually looks like. Let's see what happens if we bring it to 50. That's pretty good. So logarithmic roll-off is going to be your most realistic roll-off for the way sound actually works. But what it means is, within 1 meter, you have full volume. Then your sound volume is going to fall off very quickly as you move away. So at 10 meters, you'll see we're already down to about 0.15, closing in on maybe 0.2. And then once we get out to 40 meters, we're almost silent, and at 50 meters, we'd be out completely. So it's a very quick fall off as we move away, or roll off technically. I'll say fall off because I'm thinking of lights, but as we move away, the sound goes down very fast. Now, if we switch over to linear roll off, we have a direct one-to-one relationship. So as we start to move away, we get a nice constant drop in volume. And that may be desired for your particular sound effect. Finally, we have custom roll-off, which you can set for either one. So we can set it to linear roll-off and then switch it over to custom. And what this is going to do is allow you to change the curve yourself by just dragging some keys around. So I want to show something before I even start playing with the curve. We have a little legend down here on the very bottom. We have volume, pan, and spread. Your volume associates directly with your volume slider. Your pan associates with the pan level, and you'll see that little green dot and associated flat curve sliding up and down. And remember, pan is how much the 3D engine is affecting your sound. Keep that in mind. And then finally we have spread, which again is allowing you to spread that sound out over your speakers. And you can control that as well. The really cool thing about this is all three of these, as well as a low-pass filter, which we're not going to talk about in this video, but I just want to mention it could be in this graph as well. These can all be controlled via their own individual curves, which sounds really technical, but it's really not that bad. Let me just start with the volume, though, to keep things nice and easy. Let's say we have a really bizarre kind of curve. So I'm going to select keyframes, and really all you have to do is click on these. And you'll see you have the ability to drag them around to change the shape of the curve. You can drag their tangents around. So you can drag them straight up and down, and notice it immediately clicks over to a step curve, which is very cool. What I'm going to do is start nuking out all kinds of excess keys here. And let's grab this little tangent. Let's pull it down. So I basically just made my own linear roll-off. But to make things really cool, we're going to grab that first key, and we're going to start it at 50% volume. Now, right here in the middle, I'm just going to double-click, and notice that creates a brand new keyframe. So we'll pull this up to a value of 1, and we'll flatten it out. If we want to flatten it out and you don't want to have to try to drag it and get it just right, you can just right-click, and you have the ability to flatten the tangents. You can also set it to broken if you want, and then that way you can have the two sides do two entirely different things. And this guy will make sure is dragged all the way down to 0 so that that sound goes out completely when we hit 50. And we'll aim this back. We'll make kind of a linear relationship between, say, 30 and 50. Now, just to make sure this is all real easy to hear, let's take this first key and let's move it really close to silent. Now, before we even hit play, what relationship have we just determined? Well, we've said at a value of 0, meaning right on top of our sound, we have very little volume, roughly, I don't know, 10 to 15% of our total volume. Then as we move away, the sound is actually going to get louder until we hit about around 30 meters. And then, as we approach 50, it's going to drop off again in a linear fashion. So let's give this a quick test. So here I am, right on top of the sound, and it's very quiet. Now, take a look over in the inspector right now, and notice that there's a little tiny vertical red line with the word listener on top. This is literally mapping out exactly where you are, where the player is, technically where the listener is, in relation to this audio source. So as I back away, notice that line updates. Now it is jumping a little. Again, I'm going to keep throwing that out there. It has to do with the first-person controller and not the sound system. But notice the sound is getting louder. And here it is at full volume, and we're about 27 meters away. Now as we continue backing off, the sound gets quieter again. Until we get just outside the 50-meter range, and then it's silent, we can't hear it at all. So now we can approach it again, and there it is, it's very quiet. Getting louder. And then if we go right back up and get right back on top of the thing, it's quiet once again. So you can see how that curve mapping allows us to control that volume based on where our object is in 3D space. We can do the same for pan, we can do the same for spread. Now, to make volume a little bit easier to listen to, I'm going to set it to linear for now. And let's take a look at our other settings. Now, again, as I mentioned, pan allows us to control how much effect the 3D audio system actually has. So if I was to grab this key and drag it around, you'll notice this is actually affecting the slider. So we could say that when we're really close to the source, say around 1 meter, that the 3D engine has very little control over what this sound is doing. We want it to sound basically two-dimensional, meaning that it's just going to come through both of your speakers equally. We don't want it to pan from left to right very much. Then we can say as you move away from it, the 3D engine will get more control. So we can drop in another keyframe and move it up here and say that at about 20 meters away, give or take, 19.4 actually, then the 3D engine will have full control. Notice, though, the property up here has lost its slider, and it now says it's being controlled by a curve. Now, this is going to be a really subtle thing to listen to. In the end, if you can't hear the difference, it's just going to come down to knowing what this property does and realizing that all we're doing right now is controlling the value of that property, the value of that slider, as we move toward or away from the sound. And that's all there is to it. So right here, the 3D engine has no effect over the sound. And whether you can hear it or not, as I rotate around the audio source, I'm not hearing any distinctive left and right situation. It sounds just like I'm standing right on top of the sound, and it's coming equally into both ears. Now as I move away from it, the 3D system takes over, we get full left and right panning, and it gets quiet. So that's one way that you can use pan level to control how your sound is going to be picked up by the 3D system based on your direction. And you can do the same thing with spread. Now, spread is going to be impossible for me to demonstrate because I'm not listening on a multi-speaker system. Really, all you're going to have is whatever's coming out of the video. But you can do the same thing. You can cause, just say for instance, when your audio source is very close, you can have the spread all the way at 0, meaning it's right there focused directly on exactly where the source is. But as you're far away, we can double-click, add another curve, and say that that sound would start to spread out across multiple channels. And maybe that would be too far. You know, say we only want it to go to about 90 degrees, which would be about a quarter of the way up. That's going to start to spread it out across multiple speakers as you're really far away, making the sound like it's coming from a larger total source, and then you can focus it down as you get closer. Now, we're not here to talk about filters per se, but I do want to mention that if you have a low-pass filter applied, so if you go under Audio and you were to drop down a low-pass filter, you can also control the value of the low-pass filter using the graph. This is the only one of the effects for which you can do this. And if you like, you can create your very own curve to control this. Now, I'll talk a little bit more about the low-pass filter a little bit later, but if you just want a real quick rundown so you're not totally left in the dark, this allows you to cut off any frequencies that are over whatever value you set. And the upshot to this would be you can have the sound sound like it's getting muted by something. So if your character is going through like from one room into another and they close the door behind them, you generally expect the sound to get muted a bit. And so in that case, you'd want to start having a much more prominent low-pass filter that is going to start cutting off a lot more frequencies, and that will make your sound muted by keeping only those lower frequencies. We'll talk more about that a little bit later. So for the time being, let's go ahead and remove this back out. I just wanted to show that that was available on the graph, so you can control how much low-pass filtration is being applied from 5,000 all the way to 22,000. That's the frequencies that you'll be cutting off, by the way, based on how close or how far away you are from the audio source. Now, with that understood, I'm going to go ahead and remove this component, and this brings us down to our final sound setting, which is Pan 2D. Now, this is really only relevant if you have a 2D sound or if your pan level is set all the way to 0. So if I was to start deleting out keyframes on my pan curve, suddenly we get this back, and our pan level is set to 0. If I was to hit play at this point, and I'm not going to worry about it just because it probably won't come through very well on the videos, you can pan to the left channel, meaning your left headphone, so to speak, with a slider off to the left, and slider to the right will be all the way to the right. If this is a 3D sound, then this won't mean anything. However, you can blend in between the two. So if your pan level is, say, around 0.5, then half of the volume of the sound is coming from the 3D system and will pan from left and right. The other half is controlled right here two-dimensionally and can be panned left and right via this slider. So you have a lot of control if you play with it. So that is a rundown of the properties of the audio source. They're pretty extensive, and I realize this video is carried on now for over half an hour, but I really hope that you take a moment and throw some sound, it really doesn't even matter what sound you toss in, into an audio source and just start running around it and getting used to these. They all work in a very intuitive manner once you get the hang of them, and definitely play with this little graph because it's so cool to be able to map out all of these values based on how close or how far away you are from a given source. That, however, will wrap things up for this video. Thank you for watching.